In this lesson, we are going to be looking at how to find the prime factorization of a number. So first of all, what is the prime factorization? To answer that, we're first going to ask ourselves, what is a prime number? Hopefully you've heard of this before, and a prime number is a whole number with exactly two factors, one in itself. For example, let's take the number 5. Two factors that multiply together to get 5 are 1 times 5. Two factors. There's no other combination of numbers that multiply to get 5. Let's take the number 8. 8, you could do 1 times 8. You could do 2 times 4, so it has 4 factors. So this is not a prime number. So a prime number is a number that the only two factors are 1 and itself. No other combination of numbers can multiply to get that number. The opposite of that would be a composite number. If it's not prime, the number is composite, and that means that it has more than two factors. We saw the number 8. Let's take another number like the number 16. You could go 1 times 16, 2 times 8, 4 times 4. So here you will see 5 factors. So that's a composite number. So the prime factorization is going to be where you're going to find all the factors or the numbers that multiply together to get the number, but all of those have to be prime numbers. So the first thing we're going to do is we're going to think about what the prime numbers are. Now, in the past, you may have done this with something that they call the tree, where you make a little tree like this. And I'm going to show you another method that works really well for me, and I want to share it with you because when you do it, all of the prime factors are right here in a nice little row, and they're easy to find. It works the same as the tree, but I call it the ladder method. And to do this method, first of all, you need to know what the prime numbers are. Now, if you don't know, if you're taking notes, you probably want to write these or look at these numbers. These are the first 1, 2, 3, 4, 5, 6, 7, 8, 9. First 9 prime numbers. Now, of course, they keep going, but this is probably enough to do the prime factorization. 2, 3, 5, 7, 11, 13, 17, 19, and 23 are all prime numbers. The only factors they have are 1 in itself. We're going to use these prime factors. So this is how you do this method. If we wanted to find the prime factorization for the number 72, what you're going to do is always start with the smallest prime number, which is 2, and you're going to ask yourself, is 72 divisible by 2? Well, anytime it's an even number, it is divisible by 2. So we're going to start there and divide it by 2. 72 divided by 2 is 36, so we put on the next part of the ladder. Now, when you go to the next number, again, you're going to start here at the smallest prime number. And again, you're going to ask yourself, is it divisible by 2? And you're going to keep doing it by 2 as long as it is an even number. That's an even number. It is divisible by 2. 36 divided by 2 is 18. 18 is also an even number. It's divisible by 2. That would be 9. Here's the first number we've come across. It's not an even number, so it's not divisible by 2. So when it's not even and not divisible by 2, you're going to go to the next prime number, which is 3, and ask yourself, is it divisible by 3? Sure enough, 9 is divisible by 3, and 9 divided by 3 is 3. So what we have right here are all the prime factors that multiply together to get 72. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24, and 24 times 3 is 72. So you can multiply all these factors together to make 72, and all of these numbers are prime numbers. So we call it the prime factorization. Now, when we write the final answer, we usually write it in what we call exponential form. That means we write it with exponents. So what's another way to write 2 times 2 times 2? Well, we can write that 2 to the third power. What's another way to write 3 times 3, but 3 to the second power? So this is how we write the number 72 in prime factorization. This means 2 times 2 times 2 times 3 times 3 are all the prime factors that multiply together to get 72. Okay, we're just going to keep practicing on this. Now, if the number is negative, right here you see a negative. The first thing you're going to do is you're going to divide it by a -1 to get rid of the negative. I'm going to do that at the end. But you will have to have a -1. So the first thing you do when writing down your prime factors is say, okay, it's negative, so I know I have to multiply it by a -1 in order to make this number negative. Because remember, when multiplying, in order to get a negative number, one or an odd number of the numbers have to be negative. So as soon as you see this negative, just go ahead and write down -1, and now you're ready to start. Okay, again, remember, if it's an even number, we're going to start by dividing by 2. 240 is divided by 2. That is 120. 120 is still an even number. It's divisible by 2. That would be 60. 60 is still an even number, divisible by 2, and that is 30. 30 is an even number, divisible by 2, and that is 15. Now here's the first number we have that's not an even number. So now we go to the next prime number, which is 3, and we ask ourselves, is it divisible by 3? Well, it is. And 15 divided by 3 is 5, and what we know about 5 is that it is also a prime number. So this is good. We have out here all of the prime factors that multiply together to get 240. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 3 is 48. And 48 times 5 is 120. So when we're going to write this in exponential form, we look up here, we have 2 times 2 times 2 times 2, 4 times. So how can we write that with an exponent? We write 2 to the 4th power times, we have 1 3, so we're just going to say times 3, times, and we have 1 5, so we just write 5. So here is -240 written in prime factorization. Watch out for negatives. If it's negative, make sure you put that -1 down first, or you will not get a negative. Okay, we're just going to keep practicing. The prime numbers are 2. The next one is 3. Then we have 5, 7, 11, 17. Hope I didn't forget. Oh, I left out 13. 13. Oh, make that a 3. 17. That's probably enough. Okay, so always start, if it's an even number, we always start with 2. So 88 divided by 2 is 44. 44 is even, divisible by 2, and that is 22. Even number, divisible by 2, and that is 11. What do we know about 11? It's a prime number. So as soon as you get down to a prime number, here is our prime factorization. You could check it. 2 times 2 is 4. 4 times 2 is 8. And 8 times 11 is 88. So how do we write that in exponential form? 2 to the 3rd power times 11. The next one we have is -60. Again, it's a negative number, so the first thing we're going to do is write down a -1. 60 is even, so we divide by 2. 30. 30 is even, we divide by 2. That's 15. 15 is not even, so we go to the next prime number, which is 3. Is it divisible by 3? It is. And that would be 5. 5 is prime, so we're done. So to write this in exponential form, we would write -1 times 2 to the 2nd power times 3 times 5. 104, we're going to try it again. It's an even number, so we divide by 2. That would be 52. 52 is an even number. We divide by 2. That would be 26. 26 is an even number. We divide it by 2, it's 13, and 13 is a prime number. Once you get down to that last prime number, you are done. So 2 times 2 is 4, 4 times 2 is 8, and 8 times 13 is 104. So we write it in exponential form as 2 to the 3rd power times 13. Here's the number 198. Divide it by 2 because it's an even number. That would be 99. 99 is not even, so we go to the next prime number, which is 3. Is it divisible by 3? It is. 99 divided by 3 is 33. 33 is not even, so we go to 3. It's divisible by 3. That would be 11. 11 is a prime number, so we are done. So in exponential form, that would be 2 times 3 squared times 11. We're going to take it one step farther now and look at it what it looks like with algebraic, and it has variables involved. So we're going to do the same thing, but we're going to also have variables with exponents. So when it says to factor each monomial, a monomial is one term that involves a coefficient and variables with exponents, no pluses or minus signs, and we want to break it down. So we're going to start with the coefficient, or the number in front of the variables. Is 11 a prime number? Well, it happens to be a prime number, so we don't have to break that down any. So that's just 11. R to the fourth power. What do you multiply together to get R to the fourth power? Well, it tells you right here that you have 4 of them. So that's R times R times R times R. We're breaking it down. Next, we go to the next variable. We have S. If there's no exponent on it, it's an invisible one, so we know how there's one S. So we write times S. So 11 R to the fourth power times S would be 11 times R times R times R times R times S. In our next example, we have a negative number, so we know we're going to start with a negative 1. Then we have the number 28. That's not prime, so if we break it down really fast, 28 is even, divide by 2, which is 14. 14 is even, divide by 2, that's 7. 7 is a prime number. So we see here the prime factors. So we write down 2 times 2 times 7, or right here in its place, you can write 2 squared. Then we have to break down each variable. We have 2 A's, so we say times A, and we have 3 B's, so we say times B times B times B. That is factoring negative 28 A squared B cubed. Okay, we're going to try this again. We have 10xy. First we look at the number. 10 is not prime. It's even, so we divide by 2. 5 is prime, so we know that 2 times 5. And then we have 1x, and we have 1y. So that one is simply 2 times 5 times x times y. So if we were to multiply this, 2 times 5 is 10, 10 times x is 10x, and 10x times y is 10xy. Go right back to what we started with. In the next one, notice we have a negative number. So the first thing we're going to do is write down a negative 1. We have 18. 18 is not prime. It's even, so we divide by 2, which is 9. That's not even, so let's check 3. Can we divide by 3? We can. 9 divided by 3 is 3. That's a prime number, so we know it's times 2, times 3, times 3. There's one invisible m right there. There's one m, and there's 4 n's. 1, 2, 3, 4. There is negative 18m n to the fourth power in prime factorization, in factored form. Okay, so just as an aside, there's not another example up here, but if when doing the ladder method, let's take the number 25. This is not even, so we can't divide by 2. The next prime number is 3. That's not divisible by 3. So we have to go to the next prime number, which is 5. So we're going to divide by 5. And 25 divided by 5 is 5. So the prime factorization is 5 squared. So what happens when you have this list of prime numbers, if this one doesn't work, you go to the next one. If it's not divisible by 3, you go to the next one. If it's not divisible by 5, you go to the next one. And you keep going until you run across one that it is divisible by. So I hope this helps with finding the prime factorization of numbers and factoring monomials.